Good afternoon or evening. This is Chapter 5, Section 4, Day 2. So yes, today in class we worked on adding and subtracting complex numbers. We solved equations and saw where complex numbers came from. Today what we're going to do is we're going to go back over yesterday's notes and talk about multiplying and dividing complex numbers. Remember, in all of these notes, I squared equals negative 1. That also tells us that the square root of negative 1 is I. That's the basis of all of this. Standard form, we recall, is A plus BI, where A and B are real numbers. A is the real part, BI is the imaginary part. So if I want to go ahead and multiply this out, this first one I want to distribute the negative I. Negative I times 3 is negative 3I. Negative I times I is negative I squared. Well, I know that negative I squared is negative 1. So negative times negative 1 is positive 1. Putting this in standard form, it's 1 minus 3I. Very straightforward. Letter B, over the weekend when I did these notes, I did all of this in with using FOIL. What if you use the box method? The box method works the same way. Up in the top, I would do 2 plus 3I. On the right, I would do the negative 6 minus 2I. Draw my box, my little squiggle in the middle, and I multiply boxes. 2 times negative 6 is negative 12. 3I times negative 6 is negative 18I. 2 times negative 2I is negative 4I. And negative 2I times 3I is negative 6I squared. But remember, negative 6I squared, the I squared is negative 1, so this is negative 6 times a negative 1, which gives me a positive 6. So I want to combine like terms. My like terms are the negative 18I and the negative 4I gives me negative 22I. The negative 12 and the 6 gives me negative 6. So my final answer is negative 6, negative 22I. This last one, as I look at this, the first thing I need to recognize is that these two are complex conjugates. They are exactly the same thing, but the signs are different. So when I multiply this out, I need to remember, I need to know that my answer should just be the real part, just be a real number. Again, if I use the box method, up at the top I put 1 plus 2I. On the left, I put 1 minus 2I, which is a negative I. I draw my box. 1 times 1 is 1. 1 times 2I is 2I. 1 times negative 2I is negative 2I. 2I times negative 2I is negative 4I squared. Remembering that the I squared is negative 1, this gives me positive 4. 2I and negative 2I cancel, leaving 1 plus 4, which is 5. Just the real part, a real number. Complex conjugates will always give me real numbers. That's multiplying. Day 2, seeing multiplying for the second time. Let's look at division. Write the quotient 5 plus 8i divided by 1 minus 2i as a complex number in standard form. Again, remembering that I squared is negative 1. When we did this over the weekend, recall that 5 plus 8i over 1 minus 2i. I don't want a complex or imaginary number in my denominator. I need to get rid of this 1 minus 2i. How am I going to do that? I'm going to multiply the denominator by my complex conjugate, 1 plus 2i, because it's going to give me a whole real number. A real number. That's what I want. So what I do to the denominator, I also have to do the numerator, 1 plus 2i. So if I multiply the denominator, remembering that these now are products, 1 times 1 is 1. First, outer, 1. Let's do this as a box method, just to remember the box method. So I'm going to go ahead and do 1 minus 2i, 1 plus 2i. Draw my box. 1 times 1 is 1. 1 times negative 2i is negative 2i. 1 times 2i is 2i. Negative 2i times 2i is negative 4i squared, which is negative 4 times negative 1, which is 4. The 2i's cancel, and I'm left with 5. So my denominator is 5. Let's try my numerator. My numerator, again, using box method. 5 plus 8i, 1 plus 2i. Draw my box. One times 5 is 5. 1 times 8i is 8i. 5 times 2i is 10i. 8i times 2i is 16i squared. Remembering that I squared is negative 1, so this is 16 times negative 1, or negative 16. 5 minus 16 is negative 11. 8i plus 10i is 18i. So this is negative 11 plus 18i over 5. I can then break this up into a real part and an imaginary part. Negative 11 fifths plus 18 over 5i. There's my final answer. Reduced and in standard form. Let's try one more of these. So again, 4 plus 3i equals, 4 plus 3i divided by 2 minus 5i as a complex number in standard form, a plus bi, remembering that I squared equals negative 1. So again, I start with 4 plus 3i over 2 minus 5i. I want to not have a complex number in my denominator. I want to only have real numbers. So I have to multiply by my complex conjugate, 2 plus 5i, to top and bottom, 2 plus 5i. I multiply these out. Again, I'm going to use the box method just because it's nice. I personally like to do the denominator first because I like to see that I get that real number. It really doesn't matter which one you do first. So this is 2 minus 5i, 2 plus 5i. Draw my box. 2 times 2 is 4.